So I would like just to introduce Matthew Fhaner. Matthew Fhaner is an associate professor at the University of Michigan, Flint. Dr. Fhaner is responsible for a 2-semester analytical chemistry lecture and lab series, along with acting as the general chemistry laboratory curriculum coordinator. Dr. Fhaner is also heavily engaged in undergraduate research and professional mentorship of students, having engaged more than 30 students in independent research since joining UM in 2014. Thank you, Matthew. The floor is yours.
Thank you very much. I'm sorry. Thank you very much for the introduction. So I was ambitious, as I'm sure most of us were, in thinking what you can cover in 12 minutes. I've moved some of my slides around, but all of the actual material is still posted on the AOCS website there if you want to look at the original slides. I'm going to talk today about 2 unique experiences. One of them was an under or a lower division lab, and another one was an upper division lab. So there we go. I'm going to actually skip the background information also, just to cut down time, because the information is online if you want to learn more about me or our department. But the 2 courses specifically that I wanted to touch on was Chem 261, which is our General Chemistry 1 lab. This was for spring of last year. So just a tiny bit of background. The university closed down all on-campus functions in March of 2020. We still had spring and summer courses scheduled. So if you go back in time now, this would be spring of 2020. That general chemistry lab is a 7-week course, which historically took our 14-week fall or winter curriculum and just condensed it down. So students were generally engaging in 2 unique experiments per week over that spring term. It services majors, but a lot of non-major students as well. There were pre-assessments, post-assessments, all sorts of things with that. The other course that I'll talk a little bit about is Chem 367. We have a full analytical chemistry series, a full year. Chem 367 is our introductory analytical chemistry lab, or most other institutions might call it their quantitative analysis lab. It is a 14-week course that historically focuses on quantitative techniques like titrations and titrations and titrations and titrations. But I've thrown in some gravimetry and some calibration methods as well, just to kind of keep it a bit more contemporary. There's 1 lab per week. This usually has 16 to 24 students, also pre-lab and post-lab assessments. I want to juxtapose a little bit of what our strategies were for both of these courses as the pandemic went forward. So for Chem 261, right, I mentioned that the university stopped all on-campus activity, which caused a bit of an obstacle if you wanted to run a course, especially a lab course, which we generally realize is so important to technique-driven education, right? So the solution was to adapt the curriculum to an online virtual environment, but we didn't have one. As much of a push as there's been the past few years to put more courses online, our department had never put a laboratory 100% online. We were in the process of building a general education online course, but it hadn't been proved out yet. So we weighed the pros and cons of using some of the virtual labs that publishers had, or different companies that were actually providing kits. We kind of came to the conclusion that if we were going to move forward with this course, it had to be in-house made, because students would eventually come back onto campus to continue their general chemistry series and move into upper division chemistry series. And there were safety, notebook standards, and different technical skills we know they needed to have. So yeah, we decided we'd just make our own. And by we, I mean me. It kind of became a labor of love. And in case you were wondering, we only had 5 weeks. So most of my friends and colleagues thought I was crazy. Like, you should not do this. It's not going to be enjoyable. And to an extent, they were right, but also they weren't. I know many of us, one of the things that I really enjoyed discussing with other educators early on in the pandemic was almost the vitality that we had, because everything was the creative process over again, and we had to. So some of the things that we wanted to do that we weren't able to do, we didn't have a choice. So I'm going to skip through this slide a lot. Just basically the overlay of what my life looked like for 5 weeks was, I'm sure like most of yours, managing online learning, having all 6 of our family home, my wife working at home with myself, me wrapping up winter term courses, well, making a new lab manual, coming up with learning objectives, writing assessments, actually identifying chemicals that we could have students use at home, because remember, this is a chemistry lab. But as the title says, if you want something done, call a teacher. We find ways to do it. This was the culmination of it. So I'm going to spend some time here, or a little bit more time at least. We had 14 weeks of material for our normal fall or winter term. I took what I thought were the most pertinent skill-based experiments, so a titration, volume displacement, a synthesis with a filtration process, a calorimetry lab, and I condensed down what I thought were the most pertinent 6. One of the things that we also did normally is an observation lab, where we have students come in, and on the very first day, we give them a set of Legos, and they have to make this structure and then take notes on it, and then pass it to another student who has to use those notes. That's not really as applicable for an at-home lab. So I came up with one, which is very dryly titled The Art of Recording Observations During Experimental Activities, because that's what I came up with at first. But it was essentially an extension of something that I enjoy. I love to cook. And I had students make caramel. And while they're making caramel, if you've ever done it before, you know it's kind of a finicky process that requires time, care, and attention. They had to take detailed observations every 30 seconds without burning it, ideally, because then they would eat it if they wanted. But things like which direction the whisk was moving, how fast they were mixing, bubbles, smell changes, color changes. So we managed to come up with 7 unique labs that still integrated the learning objectives for safety. I made safety videos for each one of these. The notebook standards, I made videos on exactly how to come up with a hypothesis, what observations look like, what a data section looked like. We integrated all those into these 7 experiments. And the other big change here was, like I said, historically, this course relies on taking 14 weeks of material and condensing it to 7. I learned very early on in March that online learning and teaching is a longer and a more intense process than in person. So they had 1 experiment a week. And essentially the schedule was on a Sunday, the pre-lab assessment was released. They had until Wednesday to complete it. There were 2 Zoom sessions that I hosted, Tuesday and Thursday, for 4 hours. I'd log in. Students had to attend one of them. They could practice, work through their experiment, ask questions, go through that process. I had an office hours on Wednesday between them before the pre-assessment was due. And then the post-lab assessment was due the following Sunday. So I made sure materials didn't overlap in time, but they had a full week to explore these things on their own time in order to not overwhelm them. Unfortunately, time, as we talk about it, I'm already low on it, so I'm just going to skip ahead to essentially what we did for our in-person labs. We got the approval to have people come back into our labs in fall, but it had to be at reduced capacity. So facilities came through and actually made 6-foot bubble diagrams of all of our lab spaces where we could have students work at. This was a bit challenging for me because my analytical chemistry lab ended up with 20 some odd students enrolled, and our largest lab could only hold 16. So what it looked like on the ground for me was students would be in lab with masks, goggles, and face shields. They really didn't have to wear them when they were at their workspace, but they knew I was taking pictures, so they did. But if they were moving around, they needed to wear the face shield. This was to reduce transmission possibilities and all that. The other thing we did was I leaned heavily on a research student who was a lab assistant that term for me. And we used 2 lab spaces that were within the same floor, maybe 15, 20 feet from each other. And we used walkie-talkies to communicate real-time needs and to allow me to cycle back through each lab just to make sure that everyone was getting the experience. I also, so analytical chemistry, like I said, it's very technique-based. We kept critical things highlighted in yellow, but the other novel thing that I did was I added these 14-day cool-down periods where the class was divided into 2 groups. So for instrumental methods, we needed the UV Viz this day. Half the class would come in week 1, half week 2, which gave me 14-day periods between any time the whole class was together, again, to reduce the numbers even further and reduce risk of transmission. Be happy to answer any questions. I know that's a lot of information and a lot of fast talking in a short period of time, but I want to make sure we stay on schedule to the best that we can. So thank you.